Welcome to the Public Works Nerds Podcast.
Welcome to the Public Works Nerds Podcast. I'm Marc, and today we have a special guest co-host. Hi, Deb.
Hey, Marc.
Before we jump into today's episode, I just want to update everyone that our co-host, the co-founder of this great Public Works Nerds Podcast, has decided to step aside. He's going to take some time. He's going to pursue some other interests. So we are saying goodbye to Mr. Spack. And we're going to go with some guest co-hosts for a little while and see how that works and see what we want to do long term. But for now, we're going to bring in great people like Deb. But before that, I just want to, I want to thank Mike for his contributions to this podcast. And really, most importantly, for helping me get this podcast kicked off. Because if it wasn't for Mike, if it wasn't for the conversations that he had with me and some other people here at Bolton & Mink, this wouldn't have happened. Certainly, it wouldn't have happened when it happened. So I really am grateful to Mike for that and hope that he continues to listen. And maybe we can bring him back in as a guest for another topic, because Mike does know a lot of stuff about traffic. He's got a great background on that. So we'll see. We'll see what the future holds on that. But for now, for the rest of the season, like I said, we're gonna, I might go solo, but really I like having a co-host. So we're gonna try out some guest co-hosts and see how that goes. To finish off the first season. I don't know what a season in the podcast world is, but I kind of have it wrapped in my mind. That's at least 20 episodes. So we're gonna finish up our 20 episodes and with some co-hosts and see how that works. So, and this week, that co-host, our excellent co-host, someone that our Public Works nerds are familiar with. A few weeks ago, she did a great episode on street reconstruction and data collection for that. And so that's Deb Heiser. So welcome, Deb.
Thank you, Marc, for that kind introduction.
Yeah.
I have some pretty big shoes to fill today. And again, I just like to say Mike is an excellent person, and I sincerely hope he's listening right now. And I appreciate your support during my podcast. This is my very first time doing a podcast, and I have some big shoes to fill to try to emulate or to follow up Mike, this kind of co-host.
I'm sure you'll do great. So let's jump in back to the episode. And today we're talking to Paul Pasko. Somebody that Deb and I have known for quite a while, been very, very active in this area for a long time, and now taking his show on the road internationally. But Paul is the Vice President of International Business Development at Electro Scan. Paul's a professional civil engineer whom for the last 35 years has practiced consulting municipal engineering, primarily in the Minnesota area, right?
Started off down in Illinois.
Oh, okay.
Yeah. And then once I moved up here, it's been the Dakotas, Iowa, Minnesota, Wisconsin, Michigan, Maine. Took me out to Maine. So
wow.
I've been around.
He's been around, more so than I was even aware. But, really, during the last 18 years, Paul's become an internationally known expert in pipe condition assessment for gravity sewer and pressure pipes, and then also an expert applying trenchless technologies to rehabilitate those riskiest of pipes using techniques like lining, directional drilling, pipe bursting, and other techniques. And he's also award-winning. We love to bring in award-winning guests. And Paul has won, I'm sure you've won numerous awards, but one of the more notable ones is in 2019, he won the APWA Professional Manager of the Year Award in the Engineering and Technology category. So congratulations on that.
Thank you.
And when you look at 35,000 members of APWA, I mean, that's an honor.
Yeah.
That just shows your excellent
It was a long walk across that stage. Don't trip.
Where was that you accepted that?
That was Seattle.
That was Seattle.
2019.
The last conference before COVID.
Yeah.
Last conference before COVID.
Yeah. So why don't you take it from here, Paul? Why don't you talk about your current adventure, what you're working on right now, what Electro Scan is, and the technology behind that?
Sure. So Electro Scan is based in Sacramento, California. We have offices in Sydney, Australia, Sacramento, about an hour northwest of London, a place called Swindon, several other offices that are escaping me right now. And what we do is we put a probe in a pipe. The probe is tethered. It's a multi-sensor tool. So you have the conductivity, which is the low voltage, the star of the show. But then depending on the tool, you might also have CCTV. You might also have acoustics. And there are belts and suspenders to the conductivity tool. The conductivity runs at 11 volts of power. Provided that probe is in water inside the pipe, the voltage will make its way across that fluid to all the pipe walls. Nice tight pattern, almost like a pizza tray going down the inside of the pipe. And when it hits that pipe wall, if the pipe wall is a resistor, plastic, clay, lined metal, and if there's a defect in that pipe wall, the voltage is going to turn into electricity and come back to a grounding stake near our truck or whatever our rig may be. And that current is measured, the amount, and based on what the measurement is, we can estimate the size of the defect. I keep calling them defects because not all defects are leakers, right? And then because we're connected with a tether with a very expensive odometer on the drum, we know exactly where that is. Our tethers could be up to a kilometer long.
Oh, wow.
They could be as short as 100 meters long. English units. I'm sorry, I was working with Malaysia this morning, so I'm still in my SI mode.
Well, hopefully our listeners in Australia will appreciate the meter reference.
Yeah, there will be a few listeners in Australia.
Should we convert?
I
can't do that in my head now.
I can almost guarantee Jerry Sonarho down at Sydney Water will listen to this.
There you go.
Seeing if my proposals are actually accurate. Right? And then we have tools that go in pipes as small as a half inch. That's our water service tools. And those can, using electricity, detect whether or not lead is present in a water service line. So our rigs are pre-positioned around the world. We're a manufacturing company. Yes, we self-perform. I'm out on a lot of job sites self-performing inspections, but primarily we want to sell tools. So we sell everything that we self-perform with. And it could be as simple as a tool on a hand truck, a hand cart that you can push around, put in the back of a rental car. Very easy to put on an A380 to fly across the ocean, all the way to truck mounted, which, then those vehicles are typically pre-positioned in place to go. And what's fun about our tool is that, and this is why I went to work for them when I retired, was it's the only tool out there, in my opinion, that can tell a superintendent to within a couple, 3 backhoe bucket widths where to dig on the defect. So it's not going to be bringing back the dry holes, which is the frustration of a lot of the technologies that I used before I retired. Because in that capacity that you were so kind to read, I've used virtually every tool under the sun, sniffing dogs, the helium tracing, Utilis, the satellites whipping overhead. And this is the only one that gets you down to a couple of backhoe bucket widths. And when we pull the probe out of the pipe, the results are back within 10 minutes, which is something that, isn't out there otherwise. So give you an example, Arlington Water in Arlington, Texas just bought a couple of our rigs. And the reason they bought it is because Arlington, Texas absorbs other communities that were smaller, less organized into their network. And they have a lot of systems that they don't know the condition thereof. And they need something to go out and try and figure out, how do we start baselining our capital plan to absorb these networks into our system, water main. And they love sending their technicians out there with the hand truck cart, the 100-meter tool. It's a push tool. And they get back in 10 minutes. They have their PDF file. They have the data in their GIS system now. In a way, they go writing work orders or just, putting it off for another day and assigning a cost to it in the future CIP. So that's kind of Electro Scan in a nutshell, I think.
So take it from what your explanation is that actually the communities in the United States have purchased the technology and they're using it.
Oh, yeah.
Or the staff is actually using it.
Yeah, in the United States, we have a couple of clients in Georgia that bought the sewer units. And it's what's fun about the tool is it's plug and play. It's designed to go on Q's rigs. So you can just take a Q's CCTV truck and plug this right into the system and use the tether that's on the CCTV truck, to help operate our equipment, right? So we've got a couple of sewer tools going in Georgia. We got some in Texas. Emmy Simpson, I don't know if you use Emmy Simpson at all at St. Louis Park. They're predominant in the upper part of the United States for testing water meters and exercising valves and rebuilding valves, all those sorts of things. Simpson now owns a sewer unit, a Swordfish. That's our unit for water service pipes to detect lead. They own the Trident tool, which is the push tool for pressure pipe, 100 meters long. And they've just taken ownership of their Delta rig, which is the pressure pipe rig with the 1 kilometer of tether on it. And they're going to be offering all of those services. As a matter of fact, I'm going down to Valparaiso, Indiana on Tuesday to teach their staff how to prepare proposals to use the Delta rig because it's that new to them. And then they'll be out getting training in the field. We have an actual training facility built on a United States cold storage facilities firefighting loop that goes around their cold storage building. So we can have people out to operate the tools that they have just bought in a live pipe with live flow, because none of our tools disrupt flow or pressure. It's meant to be used while the customer is still active.
How is the tool launched into the pipe? I mean, closed system with a water main. How is the tool launched?
Well, there's a fair amount of planning involved because, quite frankly, that's the scariest part of my job is, as I've been traveling the world, I don't want to bash any owner, but the number of owners' pressure and flow models that are not accurate is stunning. You'll be told that you're connecting to 80 psi at 2 feet per second flow. You're at 100. You get out there and you realize you're at 185, and it's rolling at 9 feet per second.
Wow!
And you turn to the owner and say, "You told us it was going to be. Yeah, we'll start opening valves and throttling valves and opening hydrants, and we'll get this figured out." You had it figured out,
So there's clearly a maximum pressure flow rate that you can operate under?
Yeah, so we have a safety dump valve built into our launch tube, Deb. It's a long answer to a short question. We have a launch tube that bolts onto, the smallest would be about a 4-inch opening in the pipe. So if a municipality wants to use this, typically if we're using the push tool, 100 meter, we're going to go in through your fire hydrant. We'll have to take the bonnet off and the innards out, and we'll push down through that hydrant and get in. It's much like a sewer snake. You can twist the tether and get it to turn left, right in the T and go, full length if the pipe is clean enough, both left and right out of that hydrant. If there isn't anything like that, I was out in Cleveland last November doing an inspection on a 36-inch riveted cast iron pipe cement mortar line from 1907 right downtown. And there they put a well dot on the top of the pipe, a 4-inch well dot, and then they put a nipple on that, a 4-inch gate valve, and then we bolted onto the 4-inch gate valve, opened the gate valve, pushed down from the 12 o'clock position, and then started pushing. Same principle if you're going to use the 100-meter long tool or the 1 kilometer long tool, the Delta. We need a minimum, 4-inch opening. I usually tell owners if you're going to build an opening for us, we can get through 4, but most of our competitors need 6. So if you're going to spend the money, there's really no difference in cost between a 4-inch and 6-inch tap, in my opinion.
Right. The labor and
so get something that others can use as well, especially as the rehab market is trending towards being able to work through 6-inch openings with some of their keyway tools and things. So yeah, that's how we get in. And the tube itself that we bolt on, it's about 1 meter tall. It's about 3 inches round. Bolts on with a series of different adapters depending on what we're adapting to. I had no idea there were that many flanges out there in the world. So many different bolt patterns. Petronas may take the cake, the Petronas oil refinery I was working at, in terms of funny flanges. But anyway, you build the flange, you adapt to the base of our unit, and you put that launch tube on. It's got a chlorination/pressure cap in the top that cam locks on as the tether goes through it. There's a series of Delrin washers in there that resist up to 150 psi. Actually, they'll resist higher. But we have an emergency dump built into that if you get north of 150, it goes off and it dumps water to protect the equipment inside the pipe. And the only thing we're protecting currently at 150 is the sealings on the camera housing on some of our tools that have the CCTV. Those seals want to fail at about 150. We're always looking for seals that are better. But right now, the underwater camera people tend to orbit around 150.
150 is that's pretty high pressure.
There's a lot higher out there. I was working in Petronas 3 weeks ago, place called Penang, Malaysia. boy, you're out there when you're in Pengerang, Malaysia.
I believe it.
And we're connected to their firefighting line. They fight fires with seawater. They have a big lift station built on the coast. Strangest thing, you go through the front gates. It was 40 minutes to get to our job site. And I was told we were only about halfway across the refinery property at 40 minutes. These are enormous properties. And we're connected and we're inspecting with our Trident tool because, again, it's portable. It's easy to get in and out. And it's, this is crude, but I'm going to say it. It's our gateway drug. You bring out Trident and you let them sample for 100 meters, right?
Yeah.
And they love what they see. And then, they're inclined to want to put in an order for a Delta because who wants to do 100 meters at a time? When you're Petronas, you want to go kilometers at a time because they got a lot of pipe to look at. We got in there and we're inspecting with the Trident, the 100-meter tool, and all of a sudden their SCADA system detected that, there must be a fire in that area. So they hit us with all their fire pumps. We went from 130 PSI to probably 380 PSI in about a half a second.
Wow.
Now we've got, 60 Petronas people standing around because, we're showing off, right? Showing off our tool. Crack goes the, pressure release and you hear, and people start running because these are office folks, right? They're not used to it. My coworker, John, and I are kneeling right there with our tool. And it's like, no, we know what just happened. We're safe. Let's keep going. So we finished the inspection and they came up to us and said, well, you're done now, right? You broke your tool. We heard the crack. No, we're still good. The camera took a hit. We know we ruptured the housing on the camera, but that's just a belt and suspender to the star of the show, which is the conductivity, and the probe is fine. We're going to keep going. But, so the pressures out there are insane. I've been working with Swordfish in basements of houses in Massachusetts, suburbs of Boston. And they're at 130 PSI in the basements of houses. We pull the meter off and you connect our launch tube to their half-inch water service heading for the street and you measure 130.
Well, that water's got to hurt coming out of that shower head.
Pressure washing.
I turned to the superintendent from, I think it was Norwich, Mass. that we were at. And I said, dude, really? And he says, yeah. I says, is there some sort of PRV in this house? He says, I don't know. We'd have to ask the owner. But imagine doing your wash machine connected to 130 or your water softener or whatever. So lots of strange stuff. Lots of strange stuff.
That's amazing.
So
and our sewers.
No, you go ahead.
Yeah, okay. Our sewer rigs, those just go in through utility access structures in the street, right? So on those, you pop the downstream structure, pop the lid on the upstream structure as well. Park a jetter truck at the downstream. We own our own jetter. Typically, we use the city's jetter, and they jet from the downstream to the upstream. We pull that jetter off when it gets to the upstream, attach our probe to that end with a funnel cone. We set all that back down in the invert of the pipe. We tell the jet truck operator, turn on your water, and just let the water pour out the end of the hose. And it gets trapped by our funnel plug. Mm-hmm. And we then tell them to pull with their winch on their hose, our probe, and it stays embedded in that knuckle of water. And now the voltage is going to make it to the pipe wall because we're carrying our own water with us. If you have a surcharge pipe, so much the better. Then I don't really even need the jetter other than for the fact that I need some way to propel my tool. We talked about back to the pressure pipe, the Trident is the push. The Swordfish is a push. But then the Delta, the 1 kilometer long, that's got a hydro chute on it. So we get in there and then we ride the flow down however far we're going to go. And yeah, it's fun to do. It can be a little nerve-wracking. But like I said, owners, no fault of theirs. Models are models, right?
Yeah.
They're only so accurate, and they get a lot of good data out of us to go back and calibrate the model. I, on the other hand, get less hair. It's more gray.
Yeah.
And my hands shake more, but that's all cool at the end of the day.
Funny.
You've mentioned a couple of products. And so there's the Trident, which is a tethered for pipe. You've mentioned Swordfish.
Yep. So Trident is a 100-meter push tool meant for pressure pipe, whether it's force main or water main or any kind of process piping. Okay. Although once you dip it in sewer,
you want to do that. You got to keep that
becomes your force main tool. We strongly recommend you not go put it in your blue water van, right?
That's a good thing to bring up. I mean, when you're doing a tethered tool in potable water, disinfection. How do you make sure that the water stays clean and it's
right? So in that case, we're working with whatever the city wants us to use. I'm shocked at the number of cities, no names, but southern United States. Don't worry about it. Put it in. We chlorinate the we chlorinate the, you got that button over there?
Yeah.
We chlorinate the crap out of our water. So don't.
Paul Pasko, the first one to swear on our podcast. That's okay.
Another award to win.
Right.
It's an Electro Scan thing. That they don't care. I don't know if they don't care, if they truly do that much chlorination. But towns like that, typically I've found that the superintendent is also the police chief. Sometimes is also the mayor.
Okay.
So it's different, right?
Yeah.
And okay, that's one end of the extreme. But most communities give us their formula. Actually, they just bring out the jug of the chlorination solution already mixed, and we stand on the side with a kiddie pool, and we chlorinate the crap out of everything that's going in the launch tube and the launch tube itself. Okay. And then once we get in the pipe and we're rolling, we've that cap at the top of the launch tube that resists 150 psi or more in the case of Patronus.
Yeah.
That is full of chlorine as well. And that's a chlorine bath that wipes that tether as it goes through.
So, but then the swordfish, you brought up lead lines, and I know that that's a topic that is a hot topic right now in Minnesota. Service line. Yeah. The swordfish more of for a small diameter pipe, or what's the difference?
So swordfish is a push tool, and it's mounted. If you looked at it, you'd be like, wow, that's a Milwaukee sewer snake with a battery on it. Yeah, it is. At Electro Scan, we don't try and reinvent the wheel for getting in and getting out of a pipe. We borrow a lot of technology or buy a lot of technology from other companies to get us in and get us out of pipes. So in this case, the basis of it is either a Milwaukee sewer snake or it's tools that electricians use to fish wires through walls. We find that they're nice and bendy and they can get through all of the tortuous route that is a water service pipe. So that tool is hand carried, and it goes as small as 1/2-inch diameter pipe, depending on the level of tuberculation in there. So you push that into the pipe from the meter. Now the meter may be at the right-of-way line when we're in warmer climates. Here, of course, it's in basements. Mm-hmm. And I want to add, and just throw a shout out to St. Paul Regional Water. When Swordfish hit the market last July, St. Paul Water volunteered 4 of their customers' houses for us. So the very first swordfish inspections happened via St. Paul Regional Water with Caitlin Larson over there. So again, Minnesota, for as far out of the way as we are internationally, I don't mean that in a bad way, but the number of people when I say I'm from Minnesota, where's that? They have no clue.
Right.
Oh, we're up near Canada. Oh, so you're right by Montreal? No, go further west. We're just south of Winnipeg. What? Yeah. So, you just say, okay, imagine Seattle, imagine New York. Yeah. Go halfway across. Yeah. Oh, yeah. But for as out of the way as we are, I will give a lot of credit to Minnesota for taking shots at things first, for being the first adopters. There's a lot of risk takers up here. And quite frankly, that's what's needed. As the United States is a little bit behind, in my opinion, as I travel a lot now, in terms of trying new things and building market share for the different trenchless technologies and the new pipe condition assessment tools.
We are very risk adverse.
Not really. Not when it comes to utilities.
I just mean the public works sector.
We are. Yes, we are. Although if unless you're Mayor Mickey in that southern town I talked about, then it's like that.
That's true.
That was the place though too where we tried to get in through a fire hydrant, and they installed the hydrant at the location of a repair that they had made to their water main, and they put in a segment of PVC, and they decided they were going to tap that to put the hydrant down. Well, we got down in there with the Trident tool as we get through the bottom of the hydrant, and we're heading through the lateral to the main, and I'm looking at it on the camera. I'm like, what am I looking at? The hole through the side of the PVC they cut with a Sawzall, and it was diamond shaped. So I'm looking at it, I'm like, I can't go in there. What do you mean? Well, I can get in it, but when I'm pulling back, that diamond is going to function as a claw and a claw hammer. I'm going to get stuck. Well, you said you'd be able to get in. Yeah, but not through something like that. But here's a clue. Next time, use a tapping machine. Yeah. let's not be using chisels, sandpaper, and Sawzalls, man. But adapt, improvise, overcome, right?
How does it use GPS technology to identify where the what do we call it? Distress?
The defects are?
Defect.
No. It's got that high-end odometer.
Okay.
So that tells us how far away we are from the launch tube, and that tells us now. was working in a suburb of Kuala Lumpur last month, tracing water mains, or inspecting water mains, and it turned out that their construction plans weren't very good. And in that case, it's HDPE water main down there. They love HDPE, and they're only 6 inches of berry because there's no frost ever in Kuala Lumpur.
Right.
They're 3 degrees north latitude, right? So they're very easy to trace our probes using your regular SONs. I can't remember how many megahertz you said it. Maybe it's 512 or something like that. But then you can trace where you are in the ground. So we've had numerous clients around the world ask us to come out and find their water mains because right-of-way management is not a thing, especially in South America.
Yeah.
We've also had a lot of interest out of South America in finding water services. Why? Well, because there's so much illegal connection down there. And in some places they've asked us to work, they would have to provide us like military escort because the people that illegally tapped probably are doing things with the water that they don't want them to know that they're doing with it. And they certainly don't want a meter on it because you can't bill a cartel, right? So there's a lot of, and those jobs we've been pretty hesitant about taking because, well, you don't want to get shot at doing this stuff.
No, that's where you train somebody to do it.
Right. The local representative.
Talking
right?
about the front lines of public works.
Yeah.
Well, it's just strange. And sadly, I think it's the story that's coming here, the amount of stolen water. Actually, I have seen it in the South where they don't directly ask us to go out and find lost water services with the CCTV. But that's what they're doing. And you're starting to see a lot of people illegally tap. And the taps look fantastic, by the way, because I thought it would be drill it, put a straw in there with duct tape and tape it up. No, these are professionally done. And I said, well, how do these folks pay for this? Oh, auto parts, produce, livestock. There's a lot of bartering that goes on to get these illegal connections in. But they want a meter because of the amount of water that, say, the city of Recife in Brazil loses is just unbelievable. But, it's something that I think is just going to get worse as time goes on and people get more desperate for water. We don't have that problem here. It's fantastic to be up here.
Right. Not yet, anyway. But it's like anything. Once it reaches a certain price, then it'll be...
Right, but Swordfish it's a fun one. Pipes down to 1/2-inch diameter, and how that works is that rather than having reading particular milliamperes of power returning to our grounding stake, and in many cases the grounding stake we just attach our grounding clamp to the house's water service because in cold weather climates 9 times out of 10 that's the ground for the house, right? We're measuring the percent of the 11 volts coming back to our grounding stake. And that percentage, there's very, distinct breakoffs for the different pipes in terms of how much voltage will escape. So like your plastics, maybe only 10% of the voltage makes it back. Your your leads, 40 to 55% of the voltage makes it back. Your galvanized, you're up in the 70s, maybe 80s. And then your coppers, you're up 95, 100% back. So as the probe gets pushed into the pipe by the technician, there's a readout right on the handle of the Milwaukee. I think I saw you had the picture of it up. And the technician is seeing what percent, and they know how far they've gone because there's a little walk wheel as you're pushing the tether in. And then there's also a tablet, much like you've got there in front of you, that's Bluetooth connected. So you're seeing a plot of the milliamperes of coming back, the percentage of the 11 volts coming back on the y-axis, and the x-axis has the distance you've traveled into the pipe or the timestamp. And a lot of the owners are like, why the timestamp? Well, your water services don't follow a straight line. When I work in the Milwaukee Metro, they were paid by the linear foot back in the early 1900s to put in the water service line. So what do? They go down through the floor, they get under the spread footing, and the plumber did 2 or 3 victory laps and then headed for the street because then they could turn in that they put in 150 feet on a distance that should have only been 35 or 40. Wow. And so distance doesn't really mean anything in a lot of parts of the world, whereas timestamp that you've been in the pipe and pushing for that long, that does mean something because it shouldn't take you that long to push 30 feet. Now you're into something where there's something strange down there. Yeah. And you don't want to find it when you bring in the Corbis unit or something to grab onto that lead and use it as the pull chain to try and pull it out of the ground. because what's going to happen to that coil, it's going to pull tight. Now you're trying to pull a knot from out under the foundation. So it's good to know those things, because that might be one where you're doing some sort of a pilot auger bore to get a new water service to that house that isn't lead. And same thing, the results are back. All of our stuff, our tablets, our Trident, our Delta, they're all linked by Wi-Fi up to our app that processes the data in less than 10 minutes. That's all up on Amazon Web Service. So provided we have good Wi-Fi connection in the basement, that data is going to be back to the operator within 10 minutes as well. So if the crew that's replacing lead is right behind us, they can turn around and say, yeah, this one's got lead. Get after this one.
Hey everyone, I just want to take a quick moment to thank our sponsor, Bolton & Mink, who is producing and editing our podcasts.
At Bolton & Mink, we believe all people should live in a safe, sustainable, and beautiful community. We promise every client 2 things. We'll work hard for you, and we'll do a good job. We take a personal interest in the work being done around us. And at the end of the day, we're real people offering real solutions.
So from an application perspective, obviously this is really helpful and very pertinent and timely right now as we talk about lead services and documenting, the lead services like all agencies are required to do now.
Yep.
And eventually replace them. But outside of that, and then obviously it's good for finding those defects, the leaks.
Yep.
And such. But as we think about, and so many of our topics come back to asset management and such, but as we think about that, is this helpful for a public agency to kind of determine the condition of their pipes outside of an active leak?
Yeah, let me give you an example. I'll go back to Arlington, Texas. They had a 6-inch asbestos cement water main along the side of a road, and it was about 1,400 feet long. And the county showed up and said they're going to resurface that road this fall of 2023 and get your pipe fixed. And Arlington Water said, well, we know we've got an issue that's somewhere along the line, but we don't think we need to get rid of the whole pipe. And they wanted to be careful with that decision. They didn't have money programmed to do 1,400 feet of pipe bursting. They usually do pipe bursting, and you're pipe bursting asbestos now, right? So that raises another issue.
Yeah.
So they would prefer not to dip into that. So they said, bring that Trident out here. Let's see how we go. So they didn't have enough fire hydrants along this particular stretch of road anyway, so they put in 4 insertion points, and they installed the T and just spun it straight up to 12 o'clock position so we could bolt on easy, right? So we got in, we inspected both ways, and we found 3 distinct defects along it that they could fix with segmental repairs or outside pipe repairs. And then, okay, county, come on in. So they avoided having to spend the money on a pipe bursting job that wasn't needed in the first place. And they had one section of the pipe went underneath a creek, and they had no idea, did it offset into the road and pass over the top of the culvert? Did it go under the creek? Did it go this way? The plans were from 19, whatever. They were just a ballpoint pen line on a piece of paper. It wasn't even the scale. And because he could trace it in asbestos cement, and their depth of area is substantially lesser than ours. The CCTV, because, I didn't mention this, Trident's is self-leveling, so 12 o'clock is always up. And because we're in a water main, visibility was good. We came up on that spot where it goes under the creek, and you saw the deflection down, without a fitting, of course. And then the deflection back to horizontal, then back up, and then back to horizontal. So now they knew exactly how it was, and they're out there with their locator, and they're locating us as we went. So then they stuck a flag. The GPS comes out later that afternoon and beeps the flags and added they did.
Can you also get depth out of it then too?
I think they can.
Yeah.
We typically don't, but they interpret. I saw the guys in Kuala Lumpur. Water company there is named Air Selangor. They were playing around with depth, and I think it had to do with the strength of the signal.
Yeah.
Now they know their foundation soils down there pretty well, and the foundation soils, surprisingly, around Kuala Lumpur are remarkably consistent. I thought in tropical climates they're really varied like us. They really weren't, which was a surprise. So, and then some other things. I was working. So Caleb Peterson up at Cloquet has had us out. We used the Delta rig in a 36-inch precast concrete cylinder pipe that conveys Lake Superior water from just offshore Superior 22 miles to the Sappi paper plant in Cloquet.
Wow.
And they're, it's an interesting arrangement up there in that I believe the city owns the pipe and Sappi leases it for use, but the city is on the hook for maintaining. So they were trying to find a leak. There was a wet spot that appeared in a gravel road, tested the water, it was chlorine, so they knew it was theirs. We went out and we went through an existing air release, 6-inch air release. They took the release valve off, exposing the valve, bolted onto that, launched into the pipe. On inspection day, they had 6 feet per second for us. So grab that flow chute, and there we were 2,400, 2,500 feet out. And I'm watching how fast the tether's heading into the pipe, and any idiot can get in a pipe, and you got to get out with your data. That's the trick, right? And I'm always don't want to be that idiot, right, that can't get out of the pipe. We blow the chute. The chute doesn't float away. It stays with it, zip tied to the probe. And we start pulling back, and we would test every now and again to see how much drag have we got here, because there's a winch on our drum to help us pull back. But you have that much water going that fast. That's drag all along your tether. And then that pipe was offsetting itself vertically and horizontally as we went. So we could have probably gone the entire 3,280 feet, but we got to come home. So we made it out far enough, and then we ended the inspection and pulled back. And even if we do go out that to the end of ours, we never really go to the end. It's like fighting a fish on a fishing pole. You never let all the line off your reel, right? So you always want to have a couple of turns on there for the retrieve. But yeah, so gosh, I forgot your question.
No, just talking about like condition ratings and that, but you were using that as an example of finding that defect. So
yes,
what are the
and in the case of in the case of Cloquet, we saw the defect. It was only about a quarter of a gallon a minute, but it shone through as a defect. And in that situation, I believe Cloquet ended up taking out 3 sticks and replacing them with ductile iron. Because once they dug down, they saw the pipe was punky on the outside for a little distance either way from the joint that was destroyed.
So if it's not there's not even a minor active leak, you're not going to.
Oh no, we'll find. So
what other defects?
What other defects? Oh, this was a good one. We're working in Tucson, Arizona, and this was coming out of COVID, and this was about the time that public works workers were pushing back against coming. There was going to be some shift in policy down there, so they were going to go on strike. So we're trying to get the inspection done before they leave, because we need public works to support us, right, to operate the valves. I'm not going to touch anybody's valve. I'm not going to touch anybody's hydrant. So we get inside the pipe. This was an 8-inch asbestos cement water main, and it was underneath Interstate 5, maybe. And they wanted to know if the pipe had been damaged by recent bridge reconstruction. So we're in there, and we found that, there was a pile that got punched through, and I don't think ADOT admitted that they did it. But we, plain as day, you're in the pipe and you're watching your current coming back, and there's a consistent signal, and all of a sudden it dumped. And it dumped for a distance of 20 feet, and it came back up. Well, what's 20 feet long? Stick of pipe. So when we went back and looked at the CCTV, there it is. There's a 20-foot long piece of plastic. So I know they were going to go talk to ADOT about, hey, what happened with this bridge? And were there any other things that you didn't tell us? Then we kept on going down the way, and we began to notice that there was pipe wall loss, because all of a sudden more electricity is getting through the pipe wall for a continuous stretch, more than we would expect to see. Why is that? Well, there's less of a resistor. Why is there less of a resistor? You've lost pipe wall material. So you can see stretches of where you're starting to lose pipe wall. Now, there weren't active leaks going on there, but they're losing wall, right? And whenever I see a spot like that, I'm asking the utilities, when they do replace, if they ever replace, that they give me a coupon of that pipe, that I could send it to the lab and do the micrometering of the pipe wall and some microscopic analysis and figure out, so I can start plotting the comparison of the Electro Scan data against what's actually in the field and come up with a coefficient of determination on things like pipe wall loss.
So you can see some trends in that.
Right. Yep. And then in the case of Tucson, all of a sudden we're seeing a spike every 8 feet. It's like, well, well, the sticks of pipe are 8 feet long in this in this asbestos cement that they bought. And what happened, the superintendent turned to me and he says, oh crap, this is the pipe that we were buying from Mexico in the late 50s. Sometimes they shipped the gaskets with it. Sometimes they didn't. When they didn't, the plumbers wants to get paid by the linear foot, so they're just going to put it in without the gaskets.
Oh,
So we were seeing every joint, and it wasn't leaking. It was just a small defect, but if they dug down to look, they probably wouldn't even see water at the joint. But we proved that, every joint didn't have its gasket. So they didn't have any major leakers on that pipe, small defects, and they decided what we'll do is program out maybe 15, 20 years for a CIPP water main lining. They can lose the ID, and they like CIPP water main lining down there. So there's another example of the condition assessment. But, relative to where does the tool fall in the pecking order, most municipalities I dealt with start with a desktop model based on the data that they have in the drawer, right?
right. Age of the pipe,
Age of the pipe,
material, and
calculate a risk
break history.
score,
Yeah.
does
Yeah.
it service
Cost of
hospital?
failure.
Right.
Yeah.
Right. Yep. Likelihood and consequence. You got it. Then on the riskiest pipes, generally, and medium risk, generally that's where they'll start going out and asking us to inspect, or Xylem or Ecologics or whomever, to get that next level of data. So it's a graduated approach. Now, if you're in the United Kingdom, our guys in the UK on sewers, they're scanning everything. They don't bother, as near as I could tell, with a desktop analysis to start with. It's just get the probe in the pipe and find every defect in that run of sewer in that entire county and get it up there so that we can go through with our consultant and start deciding which pieces of pipe are coming out. Ireland is much the same way. I get to go to Belfast coming up, me working for Belfast Water, it looks like. It runs the gamut, but that is how it's plugged in. Usually the desktop analysis goes first, and as they start to drill down, that's when they start to take a look at individual parts of their pipe. Smaller communities where they have no records, they have nothing, they'll have us come in and scan everything, and we become the baseline inspection for them. A lot of our private clients are the same way. The conductivity is very repeatable, right? So you get in a pipe, and if I scan it today, like my paper company clients out in Maine, we'll scan it today, we'll see what the defects are. They'll have us back in 5 years, take another look at it. Did anything get worse? Because there they do manage by the pipe segment. They don't manage by the shot of pipe. The star of the show is the paper machine. That's what makes all the money, right? They don't want to put the money in the support infrastructure. They try and get it in the paper machines. So they literally will take advantage of every trenchless tool under the sun to do individual repairs when the plant is down maybe once every 10 years. So they invite us back, and I'm seeing people now plotting deterioration curves for individual pipe joints, where the x-axis is the year, the y-axis is the amount of milliamperes of power that came out of that defect, and they'll plot. And then as that degrades, just like pavement management, they have some threshold that they send to the people in South Africa, I guess, and they say, yeah, apply some money. So they apply some money, they lower the amount of milliamperes now because they've done some sort of repair, and then they start over and they do it again.
Interesting.
Yeah. So as more and more trenchless technology tools come on to the market in the U.S., I think you're going to see more and more people on their riskiest pipes managing by the pipe stick.
Well, let's segue into that then. Let's tap into your expertise and your knowledge about those trenchless technologies. And
I can't thank you enough for letting me talk like this. I love teaching. My job is predominantly teaching now, right?
Yeah.
Teaching and in the field. I'm living the dream. I don't have a time card. I have an expense report. Chuck, I'm the owner, Chuck Hansen, is probably going to be listening to this, but I don't have a utilization rate. So I wander the world as a nomad. My office is that briefcase on the floor. And to be able to come in and, talk about some of the things I've seen, I can't thank you enough. I'm having a great time.
Oh, this is good.
Anyway,
these stories are great.
Oh, I'm just nicking the surface.
I know. We could go on for 3 hours, sure.
You want to hear, we're doing a condition assessment on a pipe on Manly Beach in Australia.
It's really
It's about an hour. No, you know where Manly is?
Oh, I've been to Manly Beach. Yep.
All right. Well, did you walk the bituminous causeway from the there's Shelley Beach is connected to the Manly docks with a bituminous causeway about 8. What you probably didn't know is there is a 15-inch force main that runs right underneath that causeway. That's why the causeway's there. So I'm out there, doing our mission setup, and I'm turning around and I'm looking at the Coral Sea. It was the prettiest job site I have ever been on. And you may have noticed when you walked it, Deb, all the swimmers.
Yeah.
That is a huge training ground for your long distance open water swim people. And Michelle and I are those people, right? We love doing that stuff. So they were getting complaints from some of the swimmers that there was some sewage in their nasal, that they could smell
that's
it.
not good.
Like, well, we have a sewer here, so we've been working at Manly Beach, So anyway, I could go on for hours, but yeah, segue, please.
I was gonna tease him about, is he retired and traveling the world?
Yeah.
Well, yeah. Deb,
What a great way to combine.
No,
But yeah.
well, I don't want to brag, but I'm going to. Okay, so working down in Malaysia, right, for the month of June, and generally when I go overseas, I'm gone for a month at a time, kind of thing. But we get a break in the action for a weekend, so because we're on the U.S. dollar and they're on the ringgits, take every cost and divide by 4.6. So we grabbed the flight out to Borneo. And we went to the far east end of Borneo for the weekend and snorkeled on the South Celebes Sea, I think is where we were. And the visibility was like 200 feet. And we're off this island called Sipadan. And we got in a school of jackfish. And jackfish, I guess, are about the size of a tuna. I'm from Minnesota. I don't know what tuna sizes are. But you get in the middle of these schools and they swirl around you. So I'm snorkeling in the middle of a fish tornado. And I'm like, wow, this is just a weekend,
Yeah.
And then back to work on Tuesday.
Yeah,
right?
that's pretty cool.
Anyway, I didn't want to brag, but
All right, no,
Yeah.
sorry, Deb.
So getting back to nerding out.
Yeah. So let's just spend a few minutes at least nerding out about,
Yeah.
we keep talking about, trenchless technologies and what do we do when we do find the defect and, without replacing the whole pipe and everything and without tearing up the whole road.
Yep.
Talk about kind of the evolution of trenchless technologies. And I think, probably the first thing that cities felt really comfortable doing was directional bore.
Yep.
And then we got, more confidence in some other technologies and other techniques. And so, maybe talk a little bit about that evolution and what we're doing today. And you already referenced pipe bursting, but when I came to Roseville and we did our first pipe bursting thing, I thought that was the coolest thing in the world.
Oh, yeah. That still is.
Yeah.
It
So,
still is.
but yeah, just kind of talk about that evolution, starting with, we're not going to replace this whole pipe.
Sure. Evolution. Let me begin with the end in mind. In this role as VP International for Electro Scan, I get to go to some incredible shows around the world because we present there and we exhibit there. I was at one in Munich, Germany, a year ago. Can't think of its name now. It'll come to me. I was like a kid in a candy store going around and looking at all of the things coming our way. Because Europe typically is the first adopter, along with the Middle East, and then it starts working its way to Canada and then into us, right? And I can tell you that there's a lot of perfecting the mousetraps out there. People are getting smaller in terms of inspection tools to get in pipes like Swordfish, right? And people are getting bigger, meaning they can directional drill far bigger pipes. They can pipe burst far bigger pipes. They can line far bigger pipes. There are units out there that will scrub the styrenes out of the air as you're venting out of a manhole for a CIPP lining job. There are new curing rigs. The advances in UV technology for lining. The Germans are doing great work on that.
Of course they are.
The Australians. Yeah. Yeah.
When does it come into Minnesota?
Well, that's the thing. And there's the other part about beginning with the end in mind. Sadly, in the upper Midwest, I'm not just going to pick on Minnesota. This engineer has seen a reluctance to embrace the tools. And because whatever the reasons for the reluctance, contractors don't want to go out and lease or purchase this equipment. It's very expensive.
Yeah.
So unless there's market share to do it, which is driven by the St. Louis Parks of the world, and you guys are first adopters, so I'm not picking on SLP in any way. But until there's more people that are willing to take the risk, which isn't a risk anymore, quite frankly, these are proven technologies, and spend a little bit more money the first time to gain the understanding of how the tool works, we're not going to see the contractors up here. And we were talking before the podcast began that I believe St. Louis Park has moved away from structural water main lining and has gone to pipe bursting. And you're not the only ones. My friend Jeff Schoeneck down at in Omaha, they've as a public utility, they've moved away from CIPP lining and water mains as well to pipe bursting because of price. They love the lining. They love that they don't have to dig up every water service to reconnect like you have to do with pipe bursting. Much cleaner, much faster. But boy, they just can't justify the additional expense in their CIP. So,
So do you think, is that cost difference because we're not doing enough
yes,
water main lining here?
yes.
So like if we got more and more agencies to do it, that cost would come down.
If you did more water main lining, if you did more ultraviolet cure lining of sanitary sewers or storm sewers, fantastic tool. When you're in an area, before I retired, we lined sanitary sewer along Medicine Lake out by Plymouth here. The sewers were in the backyards. As I recall, there was no easement, or the easements were forgotten to be deeded back when it happens.
Yeah.
Hey, could be worse. South America, they don't worry about that. Put the pipe in, bury it, and put the house over the top of it. Man.
Yikes.
Yeah, it's stunning what I see. But in that situation, you couldn't get a steam rig out there. You're going to rut the yards. If you could get to the backyards, because where do you put it? You put it in the backyards for those old resort communities. You're not putting it in the street. The lowest spot is the walkouts to the lake, right?
Yep.
So that's where you're going to bury it, and that's where they put it back in the 70s. So there we used ultraviolet cure because they were able to put it in wagons and drag it back using pull wagons, radio flyer wagons to get back to work through the manhole lids. But, as far as I know, J.C. Dillon out of Illinois, Chris Dillon's company, he's still one of the few that's doing it and does it really, really well. Chris has been up here lining things for City of Wayzata. I think he's done a few pipes under the railroad tracks with Jen Schumann over there. So, but there needs to be more demand, and the more demand is what's going to drive these tools into here. You go around Europe, Kuala Lumpur too. Driving in Kuala Lumpur is an incredible experience if you ever get a chance. But because it's so crazy busy there 24/7, virtually everything is done trenchless. They really don't dig down there.
They can't shut a road.
They can't shut it down. And then turn a valve. They don't know what is connected to what, So all of a sudden you take down Petronas Tower? I don't think so, So the emphasis on trenchless and the number of contractors that they've got a plethora. And it's on par with digging. It beats digging. Now, some of what I'm saying, if contractors are listening, I'm sure they're going to put an X on my LinkedIn page. But, the days of dig and replace, whether you want to admit it today or not, are coming to a close. It's so much less of a carbon footprint to do it. And that's a big deal. In Malaysia, I was talking with a guy from an island off the coast that the island isn't there anymore. It's underwater. These are very real issues to people in other spots. Not us yet. We're very fortunate being 960 above sea level here, but geez, oh man. So the benefits, the less disruption to the population, that triple bottom line, economic, social,
environmental.
Good.
It checks every box.
Yeah.
But we need more contractors. And that's true on the pipe condition assessment side too.
Yeah. And that's a big common thing that I hear is we just need better tools. Eventually, more available, more accessible, and hopefully cheaper to help us assess these pipes that I can't see.
And I caution so many clients. There's a lot of algorithms that are being sold right now that, hey, give us your data. We'll wash it through and we'll give you back a desktop analysis of the risk scores on your pipes. The amount of garbage in, garbage out.
Yeah.
What they don't tell you is that, hey, for an additional fee, we'll scrub your data. So therefore you get a lot of PVC pipe that was installed in 1903. I don't think so. But it skews your scores like you wouldn't believe. And then if they were to give you that price to scrub, well, they wouldn't get the work to scrub the data. So they're giving you competitive prices that don't scrub the data. And it's like, well, St. Louis Park has their big person pants on. They should know what they're buying. Well, no, they don't, because you're not being honest with them. Come on, people. That's not how you do business. That's not how BMI does business. Yeah. You be honest, right? But a lot of people don't do that. So there's a lot of garbage in and garbage out on the market right now.
Let me kind of build on this conversation of doing the risk analysis versus actual physical inspection. St. Louis Park recently did a pilot project where we used a free swimming technology.
Yeah, baby.
Yeah, Pica. We used their CC.
Hold my beer and watch this.
There wasn't 150 PSI on that sucker.
Nope. Very good tool, by the way.
And it was a pilot for us. It was the first time. It's called Sea Snake, and
Yep.
it's Pica is the company that has
Out of Canada.
Yeah. And this is the first time in the Midwest that's been used. The results are awesome. I mean, we're looking at pipe wall thickness loss of where there's only like 4 or 5% left in some of these areas where we weren't planning on replacing the water main.
Yep.
So but when I talk about with my colleagues, why are you putting the money in investigating? You should just be putting it into replacing.
Right.
Talk about that.
Do you just go out and replace your streets, or do you have a pavement management plan?
We have a pavement management plan.
Why don't you have a pipe management plan?
Yeah.
And that's where the world is moving to. When I go into developing parts of the world, pavement management is a foreign concept to them, as is pipe management. But that's the answer, is that at the end of the day, you need to stand in front of the city manager and explain why you need the money. And you can start with the desktop, understanding that you're going to have to drill down. You cannot rely exclusively on the desktop. But at the end of the day, you only have so many dollars, and you spend the dollars in the right spot so that then the Parks Department has the money to go and build the ice sheet behind the second outdoor ice sheet, behind the rec center, because I know you already have one beautiful one. But for those reasons, money, there isn't more money out there. Unless you're a refinery, then they pull down more money than God, right? But there isn't more money. That's why you do it. That's why you guys are ahead of the curve, is because you're looking and deciding. And I would argue that probably in the next 10 years, Deb Heiser is probably going to be managing and doing 3 sticks of pipe rather than from hydrant to hydrant, because you'll be confident enough, or your superintendent of water or sewer will be confident enough in the results to say, only those 3 sticks between those 2 manholes, utility access structures, only those 2 sticks of pipe between those 2 crosses in the water main.
Yeah, I think really what the point that we have to get to, and we need to do this sooner rather than later, is a lot of agencies own their own camera system for their sanitary sewer systems.
They do, yes.
And maybe their storm sewer system, but primarily the sanitary sewer system. And we've been very good. We've been very conditioned about televising our sanitary sewers on a regular basis, jetting them, blah, 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 blah. But we know the condition of our sanitary sewers, and then we've been lining them or whatever. We need to get to that same point with our water mains. And we also need to get to the same point with our storm sewer system. And so now that means that these agencies need to buy the equipment, and they need to get trained, they need to get comfortable on how to use this equipment so that they can do these assessments, same thing that they're doing with the televising.
Yeah, like I mentioned that city in Georgia. I believe it's the city of Decatur, Georgia.
Yep.
Went out and bought their own sewer rig. Just like they have a CCTV rig, now they have a Electro Scan ES620 unit, I think, that they go out and do it on themselves. Arlington, Texas, with their Trident, they're going to go out and do it themselves, and they're going to go out and do it for other communities as well. I think there's agreements in the cities like that too, where some communities share the CCTV truck. Well, they're going to share that Trident tool, right? And, you bring up Pica. Love that tool. Inspect it many times. Have used it in smart balls many times. One of the risks with them in a city in Texas just discovered this. To get it in, you got to turn the water off, right? Or maybe in your case, you shot it through their torpedo tube. If you
we launched it. We did a launcher. It was a 12-inch pipe that we were in.
Okay, so you're able to shoot in.
Yeah.
In many cases, you have to turn the water off to set the device in and then let it go. And boy, turning water off and turning it on, especially, and I attribute this to the number of retirements in public works. There's a lot of younger people that don't have the experience of the folks that walked out the door, right? So turning water off gently, turning it back on gently. Well, this particular city didn't quite understand. They cracked their pipe 7 times along a major arterial that's a bypass around the Metroplex down there. So, and then it's free swimming, right? And the number of, when I work with Belfast Water, Dublin, Ireland, when I'm in Dublin, while we have a lot of smart balls floating around down here, we're not really sure where, but we've got a bunch of them in our system.
Oh no.
Nothing bad against smart balls.
No.
Right? I mean, I've used them. I use them a lot personally, and there is a time and a place for every one of these tools. But to have that tether on it to get it back and to be able to launch live without having to turn that water off, things that communities stop and need to think about as you get into that aspect of drilling down off your desktop.
So we are getting to the end of this podcast. This has been great. And like I said, I think we could probably go for another 2 hours. All your stories.
But the Smart Cities initiatives, that I know you're part of. You
didn't even let me ask the question, Paul. You just right into the answer.
He's listened to the podcast. Come on, Marc. He's listened to the podcast.
So talk about what's coming.
I've been fortunate enough to do these things from time to time, and truly to me it is a conversation. As you can tell, I'm kind of getting a kick out of it.
Oh, it's good.
So when I look at Smart Cities initiatives, things like that, that is the direction that this is moving. Okay, so. When you go to Europe and you see, they don't always call it that,
right?
But it's carrying those connotations, and there isn't enough of that, and quite frankly, that's the magazines, the not newspaper articles, but in our trade journals, AWWA Reporter, APWA's thing, when yes, there's some elevation that's raised that way. But it's more through things like this, things that Tony's mixing over there, that the word has to get out. Because if you don't hit people with the message in easy to share, understandable discussions, we're never going to get there.
Right.
And overseas, they've started these discussions 25, 30 years ago. And that's why it's second hat to them.
I think I need to go overseas and start learning about.
I need to go to maybe.
Yeah, we need.
Well, again, not to brag. Not.
You need a co-host.
But I need to go to Germany and see all the technology they're using over there and bring it back.
Not to brag, but I'm presenting a paper at the No Dig Down Under show in Sydney last June. And I'm out on the fantail of the boat in Sydney Harbor for their dinner cruise, and I'm like, wow, this doesn't suck. This is pretty cool. Yeah. And I'm talking to a guy, and it turns out we know the same guy in the Vancouver office of, should I say their name? Better not. But anyway, the firm, then we're like, hey, you like working at Electro Scan? And Chuck, I'm going to tell this story on the radio. But I says, yeah, I like it there. And they said, well, if you ever get bored, how about moving to Auckland? We can't find enough civil engineers, and we could really use someone with your skills in Auckland. So, we talked down and off a little bit, but I'm not at a point right now in my life that I could pick up and move to Auckland, but maybe in 3-4 years I might, Well, wouldn't it be...
You heard it here first, folks.
Wouldn't it be great to finish your career in another city? And don't underestimate the skills that you have, folks. The things that you're doing may seem passé, but you go out there in the bigger market and you will realize just how far ahead certain segments of the Minnesota upper Midwest market is.
Yeah.
The knowledge that we have here at the table would be extremely valuable in most places in Central and South America.
Yeah. But
so get out there and share.
Yeah. And I appreciate that. And we're trying and we need to do a better job of that. But I also think, to your point about, the Middle East and Europe and how far ahead of us, they are yet, we continue to learn, and there's still a lot for us to learn and try and advocate for.
One thing that the Malaysians have told me is that you got to get after the politicians more. You guys talk among yourselves at the public works level, or we did here in Malaysia 25 years ago. Yeah, we talked among each other.
Yeah.
But the people that sat the chairs, they didn't hear it, or they were buffered and only told parts of it. So, they said in America, the number one advice we'd give you is start talking to your politicians about it and explain that you can manage by the pipe segment. They probably don't know. Well, I'm sure SLP does, because you've been teaching them, right? You're good.
We've seized the opportunity to educate on the state of our infrastructure.
Yeah.
Yes, we certainly have.
Yeah. It's been fun to watch you guys do it too. A lot of the steps you're following in the path of Munich or other places like that, right? Keep going. But the politicians got to get involved.
That's a good point. Well, thank you, Paul. This is great.
Had a blast.
Lot more to unpack here on this area, this technology, and
I'm willing to come back.
I bet you are. So thank you, Paul, and thank you, Deb. Thanks for joining us today. Thanks for being my co-host today.
Well, Marc, it's been a pleasure nerding out with you. With Paul as well, and Paul.
It's great to see you guys again.
For the audience, Paul and I go back a long time, probably 30 years, I'm guessing.
Yep.
And everything I know about Trenchless technology, I learned from Paul.
Yeah.
Oh, thank you.
Most of what I learned, I also learned from Paul. So, yes.
Well, you're great students. I appreciate you listening to me.
Well, thank you again. And, one last thing before we go. If you have enjoyed this episode and the podcast in general, we ask that you help us spread the word. If you're on LinkedIn, comment on that. Don't just like it, but put a comment in. It actually helps us spread the word a lot more. And also comment on our YouTube page. We have a YouTube page, so just search Public Works Nerds on YouTube. Retweet one of our posts on Twitter, or I actually opened up or created a Threads account. So
nice.
for the 6 people that are on Threads, you can check that out too. But Instagram too. And but better yet, tell your colleagues about the podcast. We really appreciate it. We really just want to spread the word about the podcast. So thank you.
I'll spread the word as I'm traveling around.
All right. Internationally.
Why not? You could use some followers from the Middle East,
Absolutely.
right?
Absolutely.
All right.
Thank you.
Bye, guys.
Thank you.